so the reactions are favorable. Thermodynamically, their delta G is negative for the whole pathway. So it's quite typical that any breakdown or catabolic pathway yields energy, and it's also quite likely that it involves chemical oxidation, removing electrons from the molecule. So oxidation, the oxidative nature of most catabolic reaction is what provides the driving force for the pathway. So in other words, the breakdown of something like glucose or CO2, the reason that's favorable, the reason it works as an energy source for us, is because glucose is an electron-rich compound. It's being chemically oxidized. Electrons are being stripped out through oxidation. And so it's oxidation of highly reduced foodstuffs that is our source of energy. That's where we get our ATP from. So redox reactions is the study of moving electrons from one to the other, and it turns out that all the really interesting reactions in chemistry, aside from like proton donation or accepting reactions, all the good stuff in chemistry is about following the electrons, what the players are, who wants the electron most, who's got electrons, and will they share them or not. So a redox reaction is an oxidation reduction reaction. If something loses electrons, it's being oxidized. If it's giving up an electron, something else must be gaining it. So as something gets oxidized, something else is picking up the electron and being reduced. So this is really critical stuff for breakdown of foods. This reaction we saw before, where glucose is converted to CO2, that's an oxidation reaction. Lots of oxygens here on each individual carbon. Electrons are being taken out of this and given to molecular oxygen. So as this is being oxidized, the oxygen molecules are being reduced to make water. Okay, why does this happen? We'll take a minor detour into electronegativity. Covalent bonds are about sharing electrons. So if you write something like H2O, we show it as a neutral molecule. But if you really bore down into the structure, you'd see that there's more negative charge on the oxygen than on the hydrogen. Because this is a very electronegative atom. It wants to hog electron density. So while formally there's a pair of electrons in this single bond, most of the time it's residing much closer to the oxygen than the hydrogen. So we talk about the oxygen having a partial negative charge and the hydrogen partial positive